Lesson 17.2, finding x values with a given slope. It says a function f is defined by, so again we have a polynomial that's even got some trig in it. Use a calculator to find all values of x on the interval from -2 to 2. So remember, these are x values, not an ordered pair, such that the line tangent to the graph of f has a slope equal to -3. Round your answers to the nearest thousandth. So again, you won't be given a graph, but I want to show you what we're working with. So this is a cubic function. It's odd. It starts, this arrow goes down and this one ends up going up. Just things to keep in mind when you're seeing things of kind of in your head, what you should think of the picture in your head. But they want us to figure out x value. So at what points will it have a tangent line equal to -3? So it's got to be somewhere, not here, because all these tangent lines would be positive, not here where it would be a horizontal tangent line or 0. Somewhere in here is the only part where a tangent line could be negative. But the way you want to do that is put the original function into your calculator. So you've got to clear out anything else. It's x cubed plus 5 sine of 2x plus 3. Okay, and this limits the domain between x values of -2 and 2. So before I even hit graph and make sure this equal sign is dark around it so you know it's going to show up. But before I do that, I'm going to go to window and I'm going to change my x values from my minimum x value -2 to my maximum 2. And I'll still just count by 1. And I'm not going to change the y's unless I have to. So I'm going to go ahead and hit graph. And see how this function was this function. So again, I'm trying to figure out where they're negative. So if you didn't have this, you might want to do this first. Then what I would do, go back to y equals, I'm going to want to come up with the derivative equation or the derivative of this first function. So I'm going to go math, option 8, d over dx. I could type this all again in here, or to save time, go variables, vars, over to y variables or y vars, function enter, y1 enter. So that steals that and puts it in there. And then I just want x equals x. And I'm going to actually take off my first function. I don't need it anymore. And then the easiest thing to do, instead of trying to figure out where the points have a y value or a slope equal to -3, is simply put in y equals -3 as your other line. So this is y equals -3. And what that'll allow us to do is it'll create a horizontal line on our graph where y is always -3, and then we can just look for any intersection. So I'm going to go graph and see how it takes a little bit of time to load it. So something that was cubic, take the derivative and really it decreases the power, is now looking quadratic. This is where y values are -3. So again, I don't have to go through and check points. I know exactly here and here. My job is to now figure out what x values is this point at and this point at. And you can do that by going second calc, which is the trace button. Go to intersect, which is option 5. Okay, and then it'll ask you first curve question mark. You want to arrow over. I'm going to find this one first. Arrow over to where you're close to this point of intersection. Hit enter. Then it'll say second curve. Well, it'll automatically put it on the second line, which is the horizontal one. I mean, you could move it left, right, but you don't have to. Hit enter. And then guess enter. So you have to hit enter 3 times. And see how y is -3? That's what we wanted. The x value is -0.519. Okay, then I'm going to do that again. Second calc, intersect. Now I've got to arrow over to the other point. Hit enter for the first curve. Now it automatically puts me on the other one. Hit enter and enter one more time. And the other point is 0.638, comma -3. So these are the x values that I need. 0.519. 0.638. And what that's showing me is that on this graph at about -1/2, so like right in here, that this tangent line, I know this is off, sorry, but this tangent line would have a slope of -3, and about 0.638, which is more like here, would have that same slope. And you can see how they look kind of parallel, to be parallel tangent lines. Okay, so anytime you want to know where is a y value, put it in as a horizontal line and just find points of intersection.